Hello and welcome to Computer Science Principles, Activity 3.2.1, Trends in Temperature. We have looked at visualizing data in the form of Google Sheets. We have visualized data using vernier sensors and the graphical analysis app. Now we are going to try visualizing data using Python, especially the Python library matplotlib. So let's take a look at how we can get this done and what kind of information we can learn by looking at the data set and by looking at these visual representations of data in charts and graphs. So let's remember this unit is transitioning us from collecting small amounts of data with sensors or with small Google Sheets records. Now we're looking at what we're calling big data, data sets that represent large collections of data. They might be used to help people in many different ways, and in order to process and visualize and manage such large quantities of data, it's much easier to automate things rather than look at things by scrolling through, say, a Google Sheet. So in this example, we're going to look at temperature data collected for decades. We're going to see temperature readings based on temperatures, readings taken and averaged from a year, and they're going to be compared year to year. So this is going to be a larger data set, and we're going to manage it by using Python. So Project Lead the Way is going to have you work on this data. The suggestion is to download the data file. I actually downloaded it already and put it into CodeHS. So if you take a minute, you can pause this video, open CodeHS, and then come back. So in CodeHS, we are looking for Unit 3, big data, little data to big data, and we're looking for trends in temperature. We're going to start with temps analysis. And it just refers you to the directions in Project Lead the Way, which is what we're going to follow as well. So the starter code from Project Lead the Way here is exactly what is in CodeHS. Let's keep going. Locate the temperature data CSV file and open it to view its contents. So that is one of the files in our collection here. And here is the temperature data CSV file. So if we take a look for a minute, we can kind of see that this is a comma delimited text file. And we are going to find that we have a year, we have anomaly, and we have LOWESS. These are the headers, as you may have guessed, and then these are the data records that we have. So we have row 2 starting in 880, and then we keep going and going until row 140, which is more recent, 2018. Then here we have something called anomaly, which is a fluctuation, how far I think lower or higher a value is. And I'm not sure how they picked the 0. Let's see if we can find that in Project Lead the Way. But yeah, 1939 looks like it's close to 0. And lowest we're going to find out is related to the anomalies. The first column year represents the year the data was collected. The second column, anomaly, represents the change in global surface temperature relative to the average temperatures collected between 1951 and 1980. Okay, so that's what the anomaly is. That's the 0. It's the average between 1951 and 1980. The third column, low s, stands for locally weighted scatter plot smoother. It represents the estimates that can be used to fit a smooth curve through points in a scatter plot. So this is a smoothed version of the anomalies. Note, this data file has no incomplete records and requires no cleansing. Well, that's nice. So step 3, close the file. I don't think we have to worry about that. Data analysis using Python. So far in this unit, you have collected and analyzed data using the Vernier graphical analysis and spreadsheets. Despite the many features these apps have, they still require human intervention to combine, cleanse, and visualize the data. In this activity, you will explore methods to automate the data cleansing, analysis, and visualization using Python. Consider the benefits of automating this process. Why do you think automating this process can be useful? So take a minute to write down your own thoughts. Why do you think automating this process can be useful? We'll have a class discussion. Next, we're going to review the code and comments in the program. So let's take a look. Main.py. It's actually pretty short. The comments tell us that this program uses the pandas module to load a 2D datasheet into a pandas data frame object. So this is the pandas module that gets imported. The program will use the matplotlib module to plot a graph and a bar chart. And this is the matplotlib module getting imported into Python, into our Python program. So PLT, whenever you see PLT in our program, that means we are referencing the matplotlib library. And whenever you see PD in our program, like right here, that means we are referencing the pandas library. So the first thing we're going to do is load in the data with the readCSV function. We're going to use this readCSV function, which is a function of the pandas module, to take our temperature data CSV file. That's what we were just looking at a minute ago, the years and the anomalies. And we're going to load that into a data frame called temp data. The readCSV function also takes an argument header equals 0, and we're telling the readCSV function that we do have a header row in row 0. So row 0 actually isn't right here. Actually isn't data recorded. It is the header files that tell us what that data represents. So that is what we're doing at first, and then we're going to use matplotlib to make a line graph. We're going to use PLT as matplotlib. This plot function is really key. It tells matplotlib what data we're plotting. So we're going to use the temp data frame right here. And temp, by the way, is not temporary, it's temperature, where we're plotting our temperature data, where the year is going to be the x axis, and the anomaly is going to be the y-axis. And then we can assign a color to our graph. So we're going to go for gray. The y label, that's going to be just the label of the y-axis. The x label will be the label of the x-axis, which will be years. Maybe I should have mentioned the y label will be temperature anomalies in Celsius. And then every good graph deserves a title, right? The title is going to be changes in temperatures. So now that we've taken a look at this main.py program, let's see what is next for us in Project Lead the Way. We've reviewed the code and the comments. We've noticed the 2 new modules. We've explored the read CSV function. And this is a representation of what the temp data frame is going to look like. It's going to store that header row, and then it's going to start the data at row 0. It's going to call it row 0, starting with 1880. And column 0 is the first data column value, which will be year in our case. Number 7, if you changed the name of your data file, complete to-do number 1 to update the CSV file name to your file name. We didn't change any names. We can keep going. Step 8, save your work. Oh, CodeHS is going to do that for us. It's time to visualize the data on the screen. You will begin with a line graph. So a line graph displays the data changing continuously over time. It is made up of points that connect and form a line. You guys have made line graphs before. Let's keep going. Line graphs are very simple to plot with matplotlib.pyplot. Right. So we're asked to copy this code into our program. We happen to already have that. I don't know why Project Lead the Way is kind of loading this code twice, because it's also in their starter code from right up here, right? This is the same as what you would see down here. So we're going to skip that step. Observe the plot parameters. What does temp data year return? Well, it would return a list of all the years, I think, in our data frame. It returns a list containing all values in the year column. It is a very simple and powerful feature of the pandas module. So that would return all of the year values. Temp data anomaly would return a list of all of the anomaly values, right? And the last 3 lines right here, well, we already talked about that. That defines what the X label and the Y label and the title would be. Step 11, test your code. Do you see the graph? This is one of my favorite parts. Let's test it. If we run our code, what happens? Are you seeing what I'm seeing? If you try this on your own, do we see any graph? I don't see a graph. Do we see a plot title? No. Do we see an X label or a Y label? No. And why not? This is kind of a trick question. I think Project Lead the Way is trying to show us a common error that people make, and maybe because we're guided to make it as well, we'll remember what we need to do when this happens, or to avoid this from happening. So test your code. Do you see the graph? No, we don't. For the graph to appear on a matplotlib screen, you will need to add a call to matplotlib show. We need the matplotlib method show. So let's add that in. Remember, our alias for matplotlib is PLT. And if we want to call a method within that module, we need a dot. Show is the method, and we're going to use an empty set of parentheses. Let's try running this new method. Matplt.show did the trick. So now we can see from 1880 to almost 2020, I think our last year was 2018 for this data set. We see this gray line graph representing all of the values in our data set. Cool. All right. Under to-do number 3, add similar code to the plot to plot the low ESS. This is the smoothed scatter plot values in the line graph. Use another color for the line. So we have some code recommended for to-do number 3. You can go ahead and show the code if you want, or you can pretty much extrapolate it from the graph that we made already. So here's to-do number 3. Here's our code. And notice we are using a blue color to represent this line, whereas the last line was in gray, right? Test your code and make any necessary adjustments. So when we test this code, here we go. I personally do not see the second chart. But what works for me is if I remove or comment out plt.show right here, then I'm going to get the results. I'm going to show the results of all of this data being graphed in gray, as well as this data being graphed in blue, all on one chart. So let's go ahead and try that. So if you didn't already, you can comment out line 16 and take a look at what happens. So now we can really see how those smoothed values really capture the trend of the raw values, but make it a little bit easier to digest. So now we have the two lines plotted together. This is actually what Project Lead the Way was suggesting we do, which I already did, removing the first call to the show method so that we can see the two graphs together. So at this point, if you have gotten a look at these change in temperatures with the raw data in gray and the smoothed values in blue, then you are ready to kind of save your work and start thinking about what you can learn from this data. We are going to take another look at using Matplotlib to make a bar chart for our next step in the project. But for now, go ahead and make sure that you have created this chart of both columns of data. And notice, by the way, as you hover your mouse over these different values, in the lower right corner, you can see exactly what the values are. So good luck with the project. Let me know if you have any questions. And at this point, you should be able to see this data and maybe complete our exit ticket.